Now in this lesson I want to carry on with equations, but the difference today is that the equations will involve squaring. And quite a lot of squaring as well. And I'm simply going to show you the correct way of laying these out, because you know it's important to lay them out in a certain way, and you know that solve means find x, figure out what the mystery number is, but critically there's a particular way of laying it out, isn't there? So I'll show you how to do it. Now, when you're solving equations, it's important that whatever you do to one side, you do to the other side. So if I suddenly decided that I wanted to add 4 or something, I'm allowed to do that, but I'd have to do it to both sides. Now, whenever I do something to both sides, I will say that with my red pen. I'll say what I'm doing to both sides with my red pen. However, one thing you can always do is simplify an expression. When you simplify something, you don't make it any bigger or smaller, you don't change it in any way, you're just representing it with different symbols, for example. So I'm going to simplify what I can see on the right hand side there. So, because I'm not going to change the right-hand side, I won't need to change the left-hand side either. Now, you should know that 6 squared means 6 times 6, and that's 36. 8 squared means 8 times 8, so that's 64. And I haven't changed the right-hand side. I've just rewritten 6 squared as 36. I've worked it out, right? And I've rewritten 8 squared as 64. I haven't changed it in any way. On the top line, I'm adding 6 squared and 8 squared, and I'm doing the same here. This is no different. I've just simplified it. And in fact, you can go even further, because you probably know what 36 plus 64 is. 36 plus 64 is 100, and again, I haven't changed the right-hand side, so I don't need to change the left-hand side either. Now, there is one step I'm going to do to both sides at this stage. I'm trying to get x on its own, but at the moment, x has been squared. So, can you remember what the opposite of squaring is? Hopefully you can. The opposite of squaring is square rooting. So I need to square root both sides. Okay, that's an operation that we can do on our calculators. So, I hope you already know the number that you would square to get 100. I hope that's not too difficult, but I'm going to show you on the calculator the buttons to press. Opposite of squaring is square rooting, as I say, so if you square root, then that gets x on its own. That's the whole point of doing it. But on the calculator, if I want square root of 100, the square root button is this one here. This is the square root button. So I'm going to say square root of 100, press equals, and it comes up with 10. And hopefully that's what you were thinking of. 10 squared, or 10 times 10, that's 100, isn't it? So you get the answer, 10. One small added thing to be aware of, there's actually one other answer that's completely correct as well, and we touched on this a couple of lessons ago. It turns out that the number minus 10 would have worked as well. So there's actually 2 possible answers for x. So 10 is definitely right, because if you do 10 squared, it's 100, and the right-hand side's 100. So 10 is definitely the right answer. But if you square minus 10, that's also positive 100. So these equations will always have 2 answers. So those steps again, all I did to begin with was I just simplified, right? And then once I'd simplified, I square rooted both sides. That was all I did. And when you simplify, you don't change anything, so that's why it's allowed. One thing I want to point out as well, if we're using a calculator anyway, look what happens if I type in 6 squared plus 8 squared. If I type in that first line exactly as it is, it says 100 for us. So if you're using a calculator, you don't even need this second line, because typing it in the calculator, you'd go straight to that line there, wouldn't you? And then you could square root both sides. So the answer is 10 or minus 10. So another example, very, very similar, and this time I will use the calculator. So I want to simplify the right-hand side. When you simplify, you don't change it in any way, so it's not going to change the left-hand side either. Let's do 15 squared plus 8 squared equals, comes out as 289, 289. So I know all of that simplifies to 289, and that's no different, so the left-hand side is no different either. I haven't made it any bigger or smaller, and every time you just simplify, just copy the other side down, basically, because you haven't changed anything. And remember, to undo squaring, you need to square root. So I'm going to square root both sides. If you square root the left-hand side, it undoes the squaring and you're left with x on its own. But to do the square root of 289, I think I need a calculator. So I'll press square root 289 equals, and 17. Just comes out as 17 is my answer. And just like before, minus 17 would have worked as well. So the answers are 17 or minus 17. Both of those are correct answers. Okay, so far our answers have been nice, easy whole numbers, but that won't always happen. And this, I'll give you the example here in number 3. So same principle. Let's just type this in and see what happens. So let's just do 7 squared plus 12 squared, and that tells me 193. Okay. So I've simplified the right-hand side. When you simplify, it doesn't change anything, so I'm not going to change anything on the left either. But now I'm at the point where I need to do something to both sides, because I want x on its own, but I can see that x has been squared, so I need to square root both sides. When you square root this, you just get x. That was the whole point of doing it. Square rooting this, I'll do on my calculator. So square root of 193, and the calculator says, oh, that's just square root of 193. Okay, so I press this button here that says SD, and it, oh, lordy, 13.89244, blah, blah, blah. Okay, 13.89244, etc., etc. Okay, so I think we ought to round this. Okay, let's round this number. You need to come up with a sensible way of rounding it. I think something like 3 significant figures is a good idea. So if I round this to 3 sig figs, I get 13.9. So x equals 13.9, or minus 13.9, remember, either of those would work, to 3 significant figures. So I've done some rounding just to finish it off. Right, next one, again, I'm just going to type this in on my calculator. So I've got 7.4 squared plus 9.3 squared, and that equals, well, it comes up as a fraction first of all. I don't know if you can see that off the edge, it comes up as a fraction. But remember, if I press the SD button, this one here, it turns it into a decimal for me. So 141.25. And that hasn't changed anything. When you simplify, you haven't made it any bigger or smaller. So because the right-hand side is the same, the left-hand side is still the same as well. I will now square root both sides. So square root this and square root this. If you square root that, you just get x on its own. That was the whole point of doing it. And square rooting this, I'll get my calculator to do it. There is actually a shortcut here as well. Because it's the last thing I calculated, I can ask it to do square root, and then I can press this answer button, and when I press answer, okay, it displays on the screen like this. It says square root answer, but what it's doing is square root of the 141.25. It's square rooting the last thing that it worked out. So you might like that little shortcut. Okay, it comes out as a fraction, but I press SD, 11.884, blah, blah, blah. And I'm going to round that, so we should call this 11.8, or minus 11.8 will also work to 3 significant figures. So a bit of rounding was needed there. In number 5, same principle, but be careful. Look, there's a minus sign there. All right. But again, you just type it in the calculator, though. So if I type this in the calculator, it won't make it any bigger or smaller. It will just simplify it. So 12 squared, take away 3 squared, equals 135, apparently. I am now going to do something to both sides. I'll square root both sides. If you square this, square root this, it's just x. And square root this, I need my calculator, so square root of the last thing. SD, 11.6189, blah, blah, blah. If I round it, that's 11.6, or minus 11.6 would have worked as well, to 3 significant figures. I've got a couple more examples coming up. Right, number 6. This one looks a little bit different, doesn't it? This time, I mean, I want x on its own, but x has been squared. Well, that's not different. But it's got this thing added to it over on the left. So I can't start typing stuff in because, well, it doesn't look like that yet. It doesn't look like something over here that I can type in. So what I need to do is take away this 2 squared from both sides. The opposite of adding 2 squared is take away 2 squared. So that's what I'm going to do. Over on the left, if you take the 2 squared away, you've just got x squared left. Hope that makes sense. You used to have x squared and 2 squared, but if you take the 2 squared away, you're just left with the x squared. And over here on the right, 9 squared take 2 squared. Well, you can type it straight in the calculator if you want to. 9 squared take 2 squared is just some number, and it is apparently 77. Okay, it's 77. 9 squared take 2 squared is 77. Oh, and now I'm in a position where I can do square rooting again, aren't I? If I square root both sides, square root that, square root that. Square root of x squared is just x. And if you square root 77, you get 8.774 blah, blah, blah. And you can choose how to round this, or maybe the question will specify how it should be rounded. Let's stick with 3 sig figs. I've been doing that so far. That would be 8.77 then, wouldn't it? 8.77 or minus 8.77, because that number would have worked as well. 2, 3 significant figures. 2 left to go. So number 7, same idea. I want x on its own. Always, 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 the game we're playing is can you get x on its own? But look, x has been squared, and then it's had this thing added to it. I know it was that order because of BIDMAS. I know that this didn't happen first. I know it got squared first, and then some stuff was added because of BIDMAS. Okay, powers would happen before the adding of stuff. But anyway, the opposite of adding 19 squared is take away 19 squared. So you do it to both sides, take 19 squared from both sides. That's really easy over on the left, because you used to have 19 squared and x squared, but you took the 19 squared away. So you're now just left with x squared. So it's super easy over on the left. Actually not that difficult on the right, because you just type it in a calculator. So 24 squared, take 19 squared is 215, apparently. 215. And then you should by now recognise the way of undoing squaring is square rooting. So if I square root both sides, the square root of this is just x, and the square root of this I get on my calculator, don't I? So square root of 215 is, if I press SD, 14.6628, etc., etc. And I'm going to round this. So we'll call that 14.7 if I go to 3 sig figs. Don't forget that minus 14.7 would have worked as well. Last one. This time I am going to do the simplifying thing, but I'm going to simplify on the left first of all. So when I first showed you this, I showed you can simplify on the right by just typing things on the calculator, but you can actually simplify the left as well. Notice here how we've got 3x squared plus another 6x squared. Well, 3 things add 6 of those, 3 things add 6 more of those things is just 9 of those things, right? So I think first of all, I won't do stuff to both sides. I'll just simplify. I know that that and that is 9 x squareds, and I've also got this 5 squared going on, like so. I want x on its own, but x has been squared and times by 9 and had this thing added to it. So let's take that away from both sides. Let's take 5 squared from both sides. On the left, that's easy, but I'll need the calculator for the right. On the left, you used to have 9x squareds and the 5 squared, but if you take the 5 squared away, you're just left with 9x squared. That was the whole point of doing it, wasn't it? The whole point of take away 5 squared was to get rid of the 5 squared. And over here, I'll type this in. What is 16 squared? Take away 5 squared. It is apparently 231. I can't square root yet. Well, you can, but it's not a good idea. Because remember, BIDMAS, the first thing that happened to x was it was squared, and then afterwards it was multiplied by 9. So to get rid of the times by 9, the opposite of times by 9 is divide by 9. So I'm going to divide both sides by 9. Divide this by 9, it gets rid of the times. Divide this by 9, I've no idea, I'll use my calculator to help. Okay, apparently it's 25 point loads of 6s. ... Don't round it yet, only round it at the very end, please. Because we still need to square root both sides, don't we? I'm expecting an answer, I guess, that's about 5, aren't I? Because I know 5 squared is 25. So let's square root both sides, and I'll be surprised if it's anything other than a number about 5 when I type it in. So square root of that previous answer is, whoops-a-daisy, SD, 5.0662. etc., etc. So there we go. Let's round this. That would be 5.07 if I'm using the same rounding as earlier, 3 sig figs, or the negative version works as well, doesn't it? Minus 5.07 to 3 significant figures. So it is the same as before. You are just doing the same to both sides. You are just undoing it, but the calculator really helps here. There's lots of occasions when you can just simplify this by typing it in a calculator, basically. And don't forget, the opposite of squaring is square rooting. So best of luck with these.